Hello everybody, thank you for watching. This is our 9.10 video on the Dalton's law of partial pressure. In this video, you'll explain the behavior of gases using Dalton's law of partial pressure and then learn how to do some calculation problems. John Dalton talked about the law of partial pressure. He said for the total amount of pressure for a mixture of gases, it equals the sum of the partial pressures of each individual gas. So that's our first key idea. The total pressure is going to equal each partial pressure of different gases. All right, so I want you to write down this key idea and remember this formula for Dalton's law of partial pressure. Let's take a look at Dalton's law of partial pressure a little bit further. He said you can use his law when you have a mixture of gases that are different. So it has to be a gaseous sample and it has to be composed of a mixture of different gases. So let's hypothetically say that we have a gas sample where we have some oxygen gas. How much oxygen gas we have? We have 4 moles of oxygen gas. Inside of this gas sample, we also have a mixture of some nitrogen gas. We're going to say that we have 2 moles of that nitrogen gas. Then we can have some argon gas also inside the mixture. We can say that we have a total of just 3 moles of argon gas. So when we're talking about different amounts of gas inside of the gas mixture, we can talk about our total number of moles in the mixture. So if you had to figure out the total number of moles in the mixture, all you would need to do is just add up how many moles of each gas you have. And you can see that's going to give us a value of 9 moles. What if now we wanted to figure out the percent of the total moles? So here we have to do a little bit of math. We know that we have 4 moles of oxygen gas inside the entire mixture, right? The entire mixture has a total number of 9 moles. So if we take 4 divided by 9 times 100, that's going to give us about 44.4% of oxygen gas. What you want to do is also find the percent moles for nitrogen and argon. When you do that, you do the same calculations. 2 divided by 9 times 100 is 22.2. 3 divided by 9 times 100 is going to be 33.3. And that's going to ultimately equal 100% because it is a percentage. Now that we have the percent of the total moles, what if now we wanted to calculate for partial pressure? The partial pressure is basically the pressure caused by the collisions of one type of the gas in the mixture. So if we take a look at oxygen gas, the many times that this oxygen gas collides against the walls of the container, it's going to have its own individual pressure. Let's say hypothetically that the partial pressure of oxygen is 2.22 atm. Nitrogen is 1.11 atm, and argon is 1.66 atm. We're just going to use these partial pressures for this example. When you add all of these partial pressures together, Dalton's law says, using the partial pressures of each of these gases, you can add them together to figure out our total pressure. So in order to figure out our total pressure, we're just going to add the partial pressure of oxygen, nitrogen, and argon together to get a total pressure of 4.99 atm. Again, what if now we wanted to figure out the percent of each partial pressure of the total gas? So what we can do is we can take the percentage of oxygen, the partial pressure, divide that by the total amount of pressure times 100, and that's going to give us the percentage. What I want you to do is take a look to see what patterns you see. What you can notice is that the percent of moles inside of a mixture of different gases and the percent of total pressure, they're actually the same. So the key idea is the percentage of the total moles and the percentage of the total pressure will be the same for any mixture of gases. Keeping that key idea in mind, we have another formula that we also use for Dalton's law of partial pressure. So this formula says N represents the number of moles. So the number of moles is going to be N. So if you wanted to figure out the number of moles of X, any of these different gases, you want to put that over the total number of moles and set that equal to our partial pressure divided by the total pressure, because we saw already that the percentage of the moles and the percentage of the pressure are going to be equal to one another. Therefore, we can relate these relationships by using this formula. Let's take a look at some calculation problems. So we know Dalton's law of partial pressure. We have two key formulas that we can use. The example number 1 says a mixture of gases contains oxygen, nitrogen, and carbon dioxide. It has a total pressure of 32.9 kilopascals. If the partial pressure of oxygen is 6.6 and the partial pressure of nitrogen is 23.0 kilopascals, what is the partial pressure of CO2? So from Dalton's law of partial pressure, we have the total pressure. We want to figure out what is the partial pressure of CO2. By doing a little bit of algebra and adding these together and subtracting them by this, you can see that our partial pressure of CO2 is going to be 3.3 kilopascals. Let's try another problem. Example 2 says a gas mixture is composed of 0.2 moles of helium, 0.4 moles of neon, and 0.4 moles of argon, and 0.1 moles of krypton. If the total pressure of the mixture is 760 millimeters of mercury, what is the partial pressure of neon? So in this problem, we have some values that are given in moles. Therefore, we're going to use this formula. Here, when you set up the problem, the total number of moles is going to be when you add up all the moles together. You're going to need your total number of moles when you're using this formula. When you set up the formula, you can see that because we want to figure out the partial pressure of neon, we need the partial moles of neon. So we're going to put the number of moles of neon over the total number of moles and set that equal to the partial pressure of neon over the total pressure. By cross-multiplying and solving for the partial pressure of neon, you can see that we have a partial pressure of 276 millimeters of mercury. What I want you to do now is please pause this video and try these two problems that are going to allow you to use Dalton's law of partial pressure. These are the two answers that you would have got if you did the problems correctly. And that concludes our video for today. Thank you for watching.